basic overview of vectors. Has anybody had physics? You talked about vectors in there some?
Yeah.
So you may have a little background on this. I did print the notes just for the sake of some of these definitions here. A vector is a directed line segment that involves both magnitude and direction. So it's similar when we go to graph things. It's going to look a lot like just plotting a point, but we're going to draw it a little differently. In a vector, the first letter represents the initial point and the second indicates the terminal point. But the ones we are going to look at today are position vectors. And so in all of our position vectors, the initial point is going to be the origin. So if I just said like vector 2, -1. If it's a position vector, that means my initial point is the origin. My endpoint is 2, -1. And we draw a little arrow on the end to show the direction. Okay, and that's all that it is. So just like plotting a point, we draw the segment in between them and then we draw the arrow to show the direction the position or the vector was traveling. Now there are a couple things that we are going to be looking at with the vectors. We are going to talk about magnitude and direction. Magnitude. Okay, a lot of times vectors are written in bold, so that bold U just means vector U. The magnitude, it looks like an absolute value with the vector in the middle. It's the square root of a squared plus b squared, which really is just kind of like if you had done the distance formula between the original point 0, 0 and your ending point AB. That's the same thing you would get. The direction angle. This is something probably new. Even if you have talked about vectors before, you may not have seen this part of it. When I talk about the direction angle, tangent of theta is equal to A over B. So those are the two big pieces that we're going to be looking at. Let's take an example. I want magnitude and direction for this. So magnitude, like that absolute value, is just the square root of A squared plus B squared. Square root of 9 plus 4. So my magnitude is radical 13. The direction angle, we have to find theta. I told you that the angle is the one so that tangent theta is equal to what? B over A. So if we're going to set this up, tangent theta equals, what is my B? Over A. Okay. I need to be able to solve for my theta. Okay. So that means we're going to have to do tangent inverse. Tangent inverse exists in which quadrants? 1 and 4. If it's a negative, which one would it be in? 4. Okay. So if I'm going to look in quadrant 4, the other way you could get that, guys, is just look at your point. If you drew this picture, if you were going to plot this vector, it's at 3, -2. What quadrant is this vector in? 4. Quadrant 4. And that's probably the easiest way, just looking at it that way. If we want to do this, let's do a reference angle. Let's make sure we're in degrees. And let's do tangent inverse of positive 2/3. So 33.69 degrees. But we knew from this original vector we're in quadrant 4. So you do 360 minus that. And we get magnitude, and our direction was our angle.
Okay, so when you did that, did you not get negative 33?
No, I put in positive 2/3 when I did my tangent inverse. Alright. Is that okay? Next thing I want to talk about, we can be asked to find horizontal and vertical components of a vector. So A and B have to satisfy this. A is equal to the magnitude times the cosine of the angle. B is equal to the magnitude times the sine of our angle. Really, if you think about like our unit circles, this was kind of like this. The unit circle had a radius of 1, so the magnitude was 1. The x was our cosine, the y was our sine. So it is actually a form of this. So, let's look at a problem. Vector W has a magnitude of 25 degrees, magnitude of 25.0 and direction angle of 41.7 degrees. Find the horizontal and vertical components. In other words, find A and B, your x and y essentially. So the horizontal. That's our A, which I just told you is the magnitude times the cosine of your angle. So our magnitude is 25. Cosine theta was 41.7. So if we type that in, and let's just do 1 decimal place here. We'll match our significant digits. We got 18.7. So the vertical, that's your y, or your b as we're calling it here, magnitude times the sine of the angle. So 25 sine of 41.7 degrees. We got 16.6. So my actual vector W then is the vector 18.7, comma 16.6. If you were going to plot that vector, what quadrant would it be?
The first.
First, because they're both positive. Good. Alright. So far, so good?
Yep.
Calculations aren't hard, but it's just learning the terminology and learning how to calculate each
Will
one.
we get those on the test?
I think you can do that. Okay. Oh, I failed to put my. Oh, you guys don't have a photo on here?
Yeah,
We have
the
photo.
photo.
So why don't I? I did include an extra slide after this because this example is going to take a little bit longer. It's going to be a little more work. I want each vector to be written in the form AB. How many vectors do I have in this picture? 3. I've got vector U here. I've got vector V. And then we've got our W. Okay, so for each of these, we need to find the A and B, the horizontal and vertical components. So let's talk about U. A is the magnitude times the cosine of theta. Do I have a magnitude here?
No.
The magnitude is just the length of this. That's what the 5 is representing. So my magnitude is 5. Do I have my angle?
No.
Yes.
Oh.
Well, can't you find the degrees?
60 degrees.
But, wait, never mind, I see one.
Yeah, sorry, it's kind of hard to see. This
Yeah.
right here is 60.
Yeah, right, Daniel.
Do I need to flip off a light? Can that help?
Yes.
No,
If
yeah.
you can see it on the paper.
Hey,
No, I didn't see it.
Yeah, it is clear on your paper. Okay. So if I do that, cosine of 60 is 1/2 times 5, 2.5 or 5/2. Okay, let's find our horizontal component. Or sorry, our vertical absolute value. So the magnitude times cosine theta. Same thing, magnitude is, I put cosine instead of sine. So 5 times the sine of 60. Let's keep it exact. Sine of 60 is radical 3 over 2. Times 5 would be 5 radical 3 over 2. So vector u is 2.5 or 5/2, 5 radical 3 over 2. Okay, let's do v. So to find our a, what is the magnitude of v times the cosine? What is our angle?
280.
V.
Where are we at?
V is my red line up here.
I don't understand.
That is 180.
We're doing the whole.
Yeah, it's saying from this positive, if you spin how many degrees? So just like on the unit circle, so 180 degrees. So what is the cosine of 180? -1, so 2 times -1 is -2. B is 2 times the sine of 180. 2 times 0 is 0. So vector v, -2, 0. Okay, vector w. So what is my magnitude of w? 6 times the cosine. What is my angle? 280. Do we know the cosine of 280? No. So we're going to do this one on our calculator. So just type in 6 cosine 280.
So we have to do the other ones not on the calculator?
Yes, if it's an angle we know, I want the exact answer. No calculator. 1.0419. Okay, so B would be our magnitude, 6 times the sine of 280. And I get
That cannot happen.
can. We're in quadrant 4. If you're plotting something in quadrant 4, wouldn't you expect x to be negative? Or sorry, x to be positive and y to be negative? Yeah. You know, if you think about v, you're on the x-axis, so you know your y has to turn out to be negative. So w is the vector, 1.0419, negative 5.99 for 9080.
I didn't even try because I was going to.
It's not too bad, is it? As long as you remember which is which, it's just a matter of plugging things in. Let's look at a more interesting problem.
Oh, yes. Newtons, I don't know what those are.
Okay, two forces of 15 and 22 newtons act on a point in the flame. here. Let's draw a picture. Okay, we have two forces acting on the same point. So let's say this is point P. I didn't really give you the directions of these forces, so I'm just going to draw. I know one of them is a force of 15, and another one was a force of 22. But what else do I know?
That the angle of 100.
Angle between these is 100 degrees. Okay. I want to know the magnitude of the resultant force. So in other words, if I were to put those two together and get some third vector here, what would that magnitude be? So I'm going to call that V.
Oh, no.
We need to find that vector.
Well, that's split in
Was that
half.
kind of like the
so-
last one?
Yes.
Well, you put it right here.
Well, the angle's split in half, so.
Oh, well, don't trust my art. Let's think about this. If I were to make, so this would kind of form a box of sorts. At least we'd have two triangles, right? If I separated that.
Yeah.
Okay. Do you guys know anything about parallelograms from geometry?
They're the same size.
Diagonals are equal. What about opposite angles? They're the same. How much do they add up to altogether? 360. Just think like two triangles would be 360.
Oh.
So that means this angle over here would also be 100. So could you tell me what this angle is right here? 80.
Or
Okay. We have a parallelogram here. Okay. Parallelograms. Opposite angles are the same. So if this is 100, this is 100. They have to add up to 360 altogether. So this would be x plus 100 plus x plus 100 equals 360. So 2x plus 200. And so we know that angle is 80. But now, we are trying to find the length of this, right? We have an angle. We have a side, because if this is 15, this would be 15. What did we just get done doing?
I was good. We did. Both sides were.
Yeah, if you think about just one triangle of this, we're trying to find this side B. I know this angle is 80, this is 22, and this is 15. Well, cosines? Okay. So b squared would be a squared plus b squared, so 15 squared plus 22 squared. Minus 2 times 15 times 22 cosine of 80. All right, type it in.
I don't care. I am trying to do my work right.
You were trying to go for it.
So I get b to be, if I want to round, these were just, didn't include any decimals. So if I was rounding to the nearest whole number, it would be 24. What would my label be?
Newtons.
Yeah. So the magnitude, or the length of that side, is just 24 newtons. That was interesting.
That's interesting.
I'm glad you think so too. Isn't it cool how everything just like
That's just so
weaves
cool.
together
I
and
just love it.
we just use law and cosines
Who
and
came up with
geometry.
that? I can't wait to use this when I'm 30.
I'm so happy. What?
I said,
We had to measure them out, like with a ruler on our paper. And distance.
Yeah.
Oh.
Yeah,
so
so
you
you
think
think
this is
it's
fun?
fun. Gives you a headache trying to count all the lines.
Okay, last thing I wanted to talk about. What's what? That's my recording. My vector operations. This is going to be a breeze. Just the operations we can do with vectors. If I say I want to take vector AB and add vector CD, what do you think we do?
Just like, B plus D.
And that's it. So you add vectors just by adding like components. Same, of course, would work with subtraction. If I want to take a constant times a vector, what do you think we would do?
Go into K, A, and KB.
Yep.
The hardest part is drawing those.
I know, I keep wanting to put parentheses.
All right, I want you guys to try the last problem on your own. U plus V, just add your like components, so -2 plus 4 is 2. 1 plus 3 is 4. Second one, -2U, just multiply both parts by -2, so we get 4, -2. Last one, 3U would be -6, 3, minus 2B is 8, 6, so then subtract. -6 minus 8